So when it comes to intro to circuits, the most basic part of circuits are going to be charge. And if you remember from chemistry, your charge is going to come from your atoms. And more specifically, it's going to come from your protons. If you remember the plus, and then the electrons or the negatives outside. So in circuits, we're mainly going to deal with the electrons. And electrons, e to the negative, are going to be its sign. And these carry a value of 1.602 times 10 to the minus 19. And the units we call them is coulombs or C. And this will be the charge of an electron. And when you have a circuit, you are primarily measuring the flow of electrons. Like a typical circuit can be something like this, where you have a voltage source or a power source with a plus and negative terminal, and then you have some sort of load right here. And the electrons will be flowing around it. And electrons actually flow from the negative to the positive like this. However, when we are measuring and we are interpreting a circuit, we measure something called a current. And a current flows from positive to negative, so it flows in the opposite way of electrons. So what do we do with these electrons and this charge? Well, we can measure the current through the charge. That is going to be I equals to the derivative of the charge through what you're measuring. So in this case, it'll be the charge through the circuit or the charge through the load. We'll carry a current of I, and its units are going to be in amps, with the unit being A. This means that currents are going to be in coulombs per second, like this. And that means we can go from current to coulomb and coulomb to current. So for us to go from current to coulomb, I'm going to fire in a charge Q for charge, and charge unit is coulomb. That's going to be the integral. All right, so let's do some practice problems with these equations. So let's say I have an equation for charge to be Q equals 1 minus e to the minus 2t in millicoulombs. And we want to find the current when t is equal to 1 second. So what we're going to do is we're going to do the derivative of the equation for my charge, or this 1 minus e to the minus 2t millicoulombs. So the derivative of this, since they're being subtracted, we can work on them independently. So 1 is going to become 0, and minus e to the minus 2t is, we're going to keep the minus sign, and then we have to bring down that minus 2t and the derivative of it. So I do minus 2t derivative, and then e to the minus 2t multiplied by it. And this is still all in millicoulombs. So the derivative of negative 2t is just going to be negative 2. So I'm going to get 2 e to the negative 2t for my I. And then I have to find it at t equals 1 second, so I plug in 1 for t. So that means my current I is going to be 2 e to the minus 2 millicoulombs. And that's going to be my final answer for my current. All right, now let's do one where we have a current and we want to find the charge. So in this example, I'm going to have a current being represented by the equation of t squared minus 1 amps. And I want to find the charge from t equals 0 to t equals 2. So what I'm going to do is I'm going to put it in the equation for charge. So I'm going to have t equals 0. and t equals 2. So integral from 0 to 2 of my equation for charge, that being c squared minus 1 dt equals q. So quickly doing the integral of this is going to be c cubed divided by 3 minus c from 0 to 2. And then plugging that all in, this is going to be 2q minus 3 minus 2, and then minus 0 over 3 minus 0. So this is just going to become 0, and this is going to be 8 over 3 minus 2, which is equal to 2 over 3. And going from amps, we'll directly go to coulombs, so my final answer will be 2 over 3 coulombs equals to Q. So that's how you solve for charge and current mathematically. And there's another thing about circuits with current, which is very, very important. So when I have a circuit like this, and the current is flowing this way, so I will be positive in this direction. And if I were to measure the current in the other direction, let's say I'm going to measure the current right here in the negative direction, this will just become negative I. So if my I was 5 amps here, it'll just be negative 5 amps here. Measuring a charge, the positive and negative only matters its direction it's flowing and not the magnitude of it. And another thing is there's two types of circuits, which you might have heard of, DC and AC. So DC is alternating current, and that means if you're to graph out the current, it'll just be a straight line like this. While AC, if you're to map out the current, it'll typically be in a sinusoidal function like this. And that means your current and AC will change with value over time, while your DC current will keep the same current over time. So AC current changes with time, current changes with time, and DC current is constant with time. All right, that's all for section 1.3 of